Okay, we're going to start off this topic talking about linear graphs, which we've just established means a straight line graph. So at this point in the topic, if you end up drawing a graph that has a curve in it, you've made a mistake. Or if you have to plot the plots and it makes a lightning bolt, you've made a mistake. All the plots that you get will be in a straight line. Whoops. Will be in a straight line, hence a linear graph. The form that a straight line graph is usually written in is y equals some x's, say 2 of them, plus or minus a number. That is the standard form for writing a straight line graph, and some of you may know that we give the number of x's the letter M and the plus 1 the letter C. Okay, and that's a general formula. We'll come back to that later in this topic, but I just want to point out to you that's the general form for writing a straight line graph. Now, you don't actually have to know too much about straight line graphs to be able to plot them, because all you have to do is choose some x values. For example, these are the standard ones I normally choose: minus 1, minus 2, minus 1, 0, positive 1, and positive 2. So I've just chosen 5 x values, and if I think about a Cartesian axis, I've chosen these 5: minus 2, minus 1, I've chosen 0, I've chosen positive 1, and I've chosen positive 2. Then we take our formula for y, and I'm going to use this as my example, and find out what y is equal to by substituting x into the equation. This should take you back to working with patterns, which was solving equations, which we did late last term. And usually this equation, right, would come from a pattern, and you've just done some work with this typical example: triangle plus another triangle plus another triangle, and so on. Okay, that's plusing 2 each time, and it's 2x plus 2 as this equation. Anyway, coming back to here, what I'm going to do is I'm going to substitute an x into the y equation. So y becomes 2 times minus 2 plus 1. With me? I just substituted in minus 2 into the value of x. So what's 2 times minus 2? Negative 4 plus 1, negative 3. So sometimes I take a shortcut here and I just make one column. I'm just going to do it 2 columns for y to show you the working. Minus 3. This one here, 2 times minus 1 this time, plus 1. 2 times minus 1? Plus 1. Okay, Ashniana, you're allowed to answer the next question. 2 times 0 plus 1. Thanks, Christy. 2 times 1 plus 1. 2 times 2 plus 1. Right? So all I've done is I've substituted in my 5 x values into a equation that tells me what y equals to get the corresponding y term. And effectively, I've now got 5 coordinates that if I plot them, should give me a straight line, because I've told you that this form is a straight line. If I get anything other than a straight line, I've made a mistake. So plotting -2 for x, -3 for y. Remember, we always plot the x first, followed by the y. The y is the vertical axis. -2, -3. -2 in this direction, and then down 3, and that's that position there, so put a cross. Next coordinate, -1, -1. X first takes us to there, -1 is here. Whoops. Put a cross. Put a cross. Next coordinate, 0, 0, 1. X first is here, go up one position, put a cross there. Notice I'm getting a straight line. If you do it in your maths grid book, you'll get even straight line. So I'm on the right track. X first, 1, 3. 1, here's 2, here's 3. And last one, 2, +5. There's 2, that's 3, that's 4, +5 is over here. Okay. Now, usually what we'll do here is take our ruler and connect all the dots. Any idea why we do that? No? Well, the reason we do that is because this formula is true for any value of x. In other words, it is true for 1.5, which has a point here, and equally true for 1.25, 1.27. It's true for all values of x, this equation is. And we represent this by a straight line because any value of x has a corresponding value of y. A negative value of x has a negative, or usually a negative value of y. Even, well, a small negative of x will actually have a positive value for y. Second example, we've got an equation, and remember you can solve any straight line or curve graph you like by applying this principle. Choosing some values of x, and it really doesn't matter which values of x, and if you want to get more detailed on the curves, say, you'll just choose more values of x. But for this work, we're just going to stick with the 5 values of x. -2, -1, 0, 1, and 2. Okay? And to find what y is, we have an equation. Minus the x value plus 5. Okay, so again, substituting, I'll make 2 columns for y. You don't have to, you could do it all in your head, but just for the illustration, -2 goes into the value of x. So you could write it all out. Y equals minus, and it's a minus minus, plus 5. Minus minus 2 is 2, plus 5 is, next line, y is equal to -1, oops, minus minus 1, plus 5, answer. Y is equal to -0 plus 5, answer. Y is equal to minus 1 plus 5. 4? People agree? And the last one, minus 2 plus 5 is... You agree, Christy? Oh, good. Take them on to a Cartesian axis, which I'm hoping you're familiar with. X is the horizontal, Y is the vertical. Minus 2 on the X, right, is here. Plus 7. Ooh. 1, 2, 3, 4, 5, 6, 7. Way over here. Use the lines in your grid book to do this, right? In your maths book. Minus 1, 6. Here's minus 1. Here's 6. 0, 5. Here's 0. Here's 5. 1, 4. 1, 4. And then 2, 3. And you'll know if you've done it right by what? Oops. Okay, use a ruler.